So I have actually two questions before I start. How many of you work in the media supply chain part of the industry? So there are a couple here. Great. And then how many of you actually have heard of Deluxe? Oh, wow. Okay. That's impressive. You're probably looking at this title and it's like, great, another archive migration to the cloud, like, who really cares, right? But we sort of have a unique problem on our hands at Deluxe in that, it's a company that's formed of a whole bunch of different companies. So there's creative, there's distribution, there's mastering, etc. I'll get into some of that. But there's a lot of archive data that's been accumulated over the last 104 or so years. So the on-prem footprint is close to about 600 petabytes of content, and that's all over multiple locations, multiple countries. It's an engineering challenge to try and figure out not only how to move that content and how to actually source it and restore it. Potentially, like if we don't need it, we can delete it, right? If we can source it from a studio, for example. But part of that is like getting the content moved over there and then actually changing the mindset for people that have been used to for the last 100 or so years to working on-prem, using systems like desktops, etc. And you're basically doing two things. You're yanking that whole support system out and you're moving it to the cloud, and then you're starting to introduce automation. So it's pretty jarring, right? So Deluxe has, like I said, there's a creative part of Deluxe and there's also a distribution part, and the distribution part is obviously what I'm going to be talking about. For those that already supply chain is old hat. There's some pretty pictures up. So at least starting off here, this is Brightburn, which eFilm, which is part of Deluxe, did the coloring for, so the digital intermediates. And if you watch that, interesting fact is that you'll notice that Brandon, who's the kid that plays the role of the superhero or anti-superhero in that movie, there's only a limited amount of red used in that, and it's only in the scenes where he appears, and it's actually toned down versus red that appears in scenes with gore. So there are these two takes on different hues that are going on in that movie. Anyway, interesting side note. And then if we look at going back to this whole notion of a century of archive, right? So this is a slate from Alien from 1979, and this is when this is like 42 years ago. VHS was just rolling into the U.S. I think around like 1977. So this is right on that cusp of VHS is coming out, and this is before things like Blockbuster and home entertainment, etc. So Deluxe was still in that mode of cutting prints, etc. So it's over the century, it's had to Deluxe has had to reinvent themselves time and time again. So this is just another permutation of that. So like I said, there's this whole notion of creative, like digital intermediate. So these are all the DIs that eFilm works on, so coloring, but there's also visual effects, etc. And then really the thing that we're going to be talking about is, there's this challenge of how do you bring that side of the business together with the content distribution side, and then build a platform to manage this large-scale archive. So there are a lot of facets to this, and it sort of goes to how you have to design a platform that facilitates onboarding these, new lines of business, if you will. We deal with localization, so there's a workforce that does that. There's theatrical distribution, so DCP distribution to cinemas around the US, for example. Obviously, digital distribution, right? So as a content or a studio opens up avails windows, depending on the rights, we can then fulfill and deliver through the supply chain and deliver those assets to, say, a distributor. So the vast majority of content that you would see serviced through the major OTT service providers has probably either been touched in a DI format or VFX format, or has been transcoded or manipulated to spec and then delivered through supply chain to those endpoint distributors. So we don't really deal with the end user in terms of the end players, the frameworks, etc. It's everything in moving that content from like an upstream perspective. And then I just wanted to give like some context on the platform, because like if I talk just about the archive, it wouldn't really make much sense. Like there's no context to it. Like, great, what does it run on? What does that look like, right? So this is sort of where we are with the platform now, and we've swung this pendulum two ways. So we swung it all the way to, everything scales horizontally. We use no things like RDS. Everything is completely cloud agnostic, and you obviously run into a lot of problems with that. So it's sort of reset somewhere in the middle now. So this is all, decoupled orchestration and then distribution of content. So these workflows get pretty complex, and there are a lot of them running at the same time, and the goal is for this all to be fully automated. So we have a small team, myself and a couple other guys, that basically handle DevOps, and infrastructure, architecture, design, etc. And the core of this platform was all built on AWS. But we've built it in a fashion that we can use things like, and this is where, for example, the HashiCorp stuff like Terraform, Nomad, etc. is really useful, because we can build a container and then we can deploy it on-prem, so that whenever those tape archives are pulling content from tape to get ready for onboard, we can then have a container deployed locally, looking at the content and then moving it into, say, S3 bucket. And then we basically have, the other important thing here is things like chain of custody, like who's touching the content, right? Because this is premium content. So the one thing that we do a little bit differently is no developers have access to S3 or AWS console or IAM or anything like that. The pipeline basically goes that you commit your code to GitHub. It's semantic version checked, and then it rolls out through the system. That's completely abstracted away from the developers. So the operational requirements here, right? So you get an idea of the platform, and now it's time to look at, okay, when we're starting to lift this content, what are we trying to do with it, right? So the vast majority of use cases for our type of delivery for supply chain is this use case called pick, pack, and ship. So in other words, we're sourcing the content, we're maybe tarballing it, which actually does happen, or we're just arranging it, creating a sidecar metadata file, and then shipping it out. So for example, that could be something coming from a studio and going to a Netflix, for example, or going to Apple, or whatever that might be. There are other use cases, so next day delivery. So this would be something like has to get pulled out of archive pretty quickly because an avails window is opened, and potentially for a launch of a product, they want to show certain types of content, right, or certain features. So if you think of maybe it's like the new Blade Runner is coming out in 2 weeks, we may need a next day delivery of the older versions to be able to get those played and get some interest for that. Complex packaging, so this is where we start to get into things like IMF, etc., DCPs, and so on. And then way on the other end of the spectrum is mastering, right? So this is where the supply chain starts to, what we don't do right now, but eventually starts to hold things like masters. And that means we can start to look at things like editing in cloud, or bringing the content back on-prem and then pushing it back and delivering it. So it's like taking those creative and those like DI type workflows and starting to try and get that working, in the cloud. I'll say a lot of that stuff is not ready for prime time right now. And there are a lot of edge cases as well. But the big thing is, if we can just move a file through the system, potentially transcode it, and then index it, we're good to go for the vast majority of content. So right now, we do about, so this is simple sizing on what we have, right? So like a DCP, that could be 500 gigs. If we're doing UHD, it's over 1 terabyte per asset for delivery. An asset in a title, there might be multiple, so it could be discrete audio tracks, etc. We have about over 1 million titles that we manage now, comprising all of these. And then when we get something ready for distribution, you may have 1 to 10,000, discrete outputs of that. So the 10,000 could be your dash HLS, non-encrypted, non-DRM'd source that we send out. When it comes back down to 1, it could be a mez that's getting, basically picked, packed, and shipped. So the other problem we had was like, how do we identify these assets? And given this chain of custody, and we actually, we can't allow developers, we can't allow most people to have any visibility into the system. So we basically abstracted all of this away from the entire platform via a service called VFS, which is basically an overlay file system. And to do this, the problem was we have all this unstructured data coming in. So if we get something coming from like a studio, they might upload a file, and then they'll upload a discrete audio file to match that, but the file is misnamed, and there's no metadata. So we need a way to sort of get that into a format that is much like an IDER, but they may not have an IDER, and that's the entertainment ID registry. And then we looked at things like UUIDs, checksums, etc. A lot of those are heavy to calculate. But the solution eventually that we arrived at, and this is unique to us just because we are on AWS, S3, etc., is that obviously the E-tag for a multi-part upload is not always unique, right? So we took a bunch of what we thought would be unique variables and hashed that together, and that forms the core of our like unique hash per asset that comes into the system. So delivery side, right? We use a lot of Aspera to deliver stuff out, and this is where we had to lift and shift the stack onto the service as well in a separate account. These numbers are actually pretty low now. We deliver about 5 to 6 petabytes of content out per month via Aspera. So each one of those EC2 nodes is running, 1.4 gigabit 24/7, pushing out content. And then there are a lot of delivery endpoints and obviously a lot of assets that get delivered. So this is something that was also part of the challenge, right? How do you, if you're onboarding these large assets, how do you easily move them out of the system as well? So what does a sample package look like? This right here is a digital cinema distribution package, but you can see just the weight of the files here as a single file. So like your ProRes 4444XQ, that's 500 gigabytes, right? It takes a while to deliver that as an order, and then you start multiplying that up, and the orchestration becomes extremely complex. And it's not always a single file. So, if you look at this is a DCP, just a dump that I took out of our asset management system. But this has all of the CPLs, and then it has the asset map and the volume index. And this is basically the actual theater presentation, the front-end trailers, the back-end trailers, the, please don't use your cell phone during, the filming, etc., all of that stuff. So you can see they're like, 10, 12, 15 gigabytes. They go down in size, they go up in size, but the payload's about 300 or so gigs. So it becomes very complex to do accounting for this and deliver all that content. So the design of the archive, there's some stuff that I've omitted from this for security purposes. And there are a couple other things where it's too complex to basically look at it because there are multiple dimensions here. So if you picture this as, this is sort of the pipeline for the system at a general whole, if you will. But for many studios, their content is serviced separately, and then you basically look at this as being stamped out for different use cases. So basically, we start with ingest into the system, and this is our DMZ that we created. So the idea for this was, as all these groups are uploading content, we can allow it to land. We have a separate KMS key for each one. We encrypt the content there, and then we're just waiting for that to get ingested into the system as it needs to get onboarded. There's a centralized, bless you, there's a centralized centralized archive, and then we basically abstract web processing away from that. So what we wanted to do there was we didn't want to let any microservices touch archive. So they have to have IAM credentials that are stored in a vault. They get access to that vault and those credentials through the whole GitHub pipeline I explained. And then once those credentials are pulled, they're able to make a request to that overlay file system service called VFS to basically say, I need this item in archive. I don't know where it is. I don't even know what the name of the bucket is, but can you get it ready in WIP for me so that I can then ask, say, a Hybrid or a media converter or some other service to transcode that for me. And then that works similar for things like data science, proxies, these could be just in time, etc. And then final delivery, which is also segmented out. So these are all segmented by these buckets running a separate account. There's an interesting thing that you can do. So you can actually, via bucket policies, you can lock out anyone except the root user having access to it, so no IAM access. And then you can actually use AWS organizations to lock the root user out with a global policy from being able to modify that either. So we use stuff like that to basically secure everything. And then quickly, just to get into, what does this look like, right? So we've been running this over the last 2 years or so at like a fairly even pace. And the interesting thing is that when you move this amount of data, you have to think about not moving it within a month because that's not even feasible, but the timeline has to be within a year. So you're moving 1 to 2 petabytes every month, but the size of that archive dictates that we have to plan to have staff around to be able to constantly swap out those drives and fix things in the span of 1 to 2 years, if not more. So this is a sample, and this we did about 2 months or 3 months ago. But I'd say this was at a point where everyone was really familiar with how this would work operationally. So we basically moved all of this in a 2-month time frame. So we had 60 racks of physical hardware, and this is for a part of the supply chain business that services things like satellite and cable providers, which is very demanding for things like TVOD, etc. So basically get rid of all those racks, take those 9,000 tapes and move them up into S3, and then lift and shift all of those 640 VMs. And at the same time, right-size that 6 petabyte Isilon cluster. So the one interesting thing we did was, and this is probably the same for a lot of other companies that do this on-prem, is that the vast majority of that Isilon cluster was, we created a transcode, we should maybe hold on to it in case this third party wants another copy of that, or they want to change it and then they want to roll back. And we're like, no, we'll just generate another order, we'll transcode it again, it's cheap enough. So that reduced that 6 petabyte Isilon cluster down to about 300 terabytes. So if you look at anything like Zadara or Cumulo or any SAN type solution in the cloud, a 6 petabyte cluster is it's cost prohibitive. So that's sort of what we took there, and then the actual migration of that. Like I said, we planned for months. We used a lot of on-prem stuff, so we used the ability for things like Nomad to schedule on-prem or use containers on-prem. The other thing we did was only object stores, so we put a mandate out, no one is to deploy SANs. And that was simply because of all of the issues that we were seeing in doing lift and shifts. I think one of the biggest things that we saw was when we shifted some of these systems and put a SAN up, even though the SAN was in 1AZ, the propensity, if you have an auto-scaling group, for the transcoders to attach to that SAN across an AZ, the bill for that was, 50, 60, 70 grand just for the cross-AZ traffic. So it was pretty essential to basically rewrite everything to be S3 and object native. And then the other thing for like moving this amount of data is you have to run constant simulations. So we run this like title ingest simulation through QA of like 20,000 titles coming in or like 5,000 orders going out. It's an edge case, but for like quick ingest of stuff that has to be stable all the time. And then the other mandate was, we're moving it, we're not moving anything back, there's no second chance. It's like move the boats and then burn them, right, once you're on the island. So, a lot of this is specific to what we're doing, but, we had some use cases where we had to move things between regions or between buckets in region. And the key thing here, and this basically using these settings and just off-the-shelf CLI tools, you can move like a petabyte archive to a DR location over the course of like a couple days. You don't have to buy commercial software to do that. You actually don't even have to take the time like we took to build something with a bunch of Go workers. We actually did one of these just using GNU Parallel, a couple bash scripts, AWS CLI. But the important thing here is to take the data set. So this is a sample of the data set and the spread between the small and large files. And then basically align that to the multi-part chunk size and the amount of requests you want to go into the queue. And then deploy that on the right-sized instance. So this instance has a 10 gig NIC, not to move the data, but to handle the back and forth chatter that's happening as all those chunks are getting moved. That's the biggest limiting factor there. So final state for the supply chain, what does that look like? I'll just step through like what this looks like when we actually process media and where it touches different parts on the supply chain. So I talked about ingest, that's got a touch point to object store, S3. We then do materials analysis, so MA is basically, we don't do things like, say, ML-based analysis of the data coming in because it's too compute intensive, if you will. So MA is basically things like extracting the metadata that's arrived with the file, maybe doing things like conformance. So even though we do use ML and AI for some of these things, the vast majority of what we're doing is just pure pixel and signal processing. So we basically found, for things like as a file arrives, there's no need to fingerprint all the frames. We know that if a master arrives, it's going to at least have 2 channels of audio. So we take that, we extract it, we make a 6 kilohertz mono track out of that, we fingerprint that track spectrally, and then we use that as a way to compare if a second audio track arrives, does it line up with the primary? So that's worked really well for us, and that the confidence that we have there for things arriving is around like 97 to 99% confidence. And we have to have that because if we don't have that, a human has to get involved, right? So if we're like in 60, 70 percentile of confidence, if we were using, say, deep learning or that type of approach to the problem, a human would have to touch it anyway. So we need to absolutely remove that step. So a couple other things here. There's a centralized workflow conductor that runs, and then we do assembly fulfillment. Like, do we have all of the files? Are they there? Are we waiting for something to arrive? We then do the transform of the content through the scheduler, so that could be transcode, it could be registering new assets that have arrived, etc. And then the final steps are, once you have all this stuff in place, is to basically process the order, package it, and then deliver it. And the one thing that's interesting from this perspective, from like if you think of like what do you need to do to meet an SLA? What about when I actually deliver the file? The SLA is like met when the file arrives in the destination bucket and the third-party distributor has access to it. So everything from Aspera going out or S3 copies going out is completely removed from that part of the equation. So, just looking at the storage growth, right? And this is sort of a interesting one. So this is part of the archive and the growth of the archive. I talked earlier about that, the on-prem footprint that we moved, the fairly large one of about like 8 petabytes or so, and that's actually this section right over here. So the blue section over here, like right at the end, you can see like this is us sort of figuring out, and ramping up, and then you get to the steady state of constant archive migration for that part of the archive. But at the same time, we start delivering orders, and you can see this WIP space here. This is about a petabyte eventually that is sitting on 500 terabytes to a petabyte. Now, this is sitting all online on S3, and we can't take it offline. So one of the things with migrating something of this size is you have to budget for that WIP that just keeps expanding, right? So that's an interesting thing that adds to the bottom line. And then this over here is this like fairly large scale, almost immediate move that we did of content. So you can see here it's going a lot faster because we're using all the tools that we built over there. We're just doing it a lot quicker now. And then finally, just like what takeaways would you get out of this, right? So I think, we were approached, and obviously we had a lot of commercial vendors in the mix, and we still do, but for the vast majority of actually sourcing and moving everything of this size, we either built the tools ourselves using Go, or we used open source tools out there, or we just use things like AWS CLI. So you don't really need commercial software. You don't need an on-prem hardware device to do this. You don't need anything fancy to do it. You just need to plan for that like 6 to 12 to 18 months and that deterministic month-over-month calculation of how much content can be moved. So I talked about SANs and lift and shift. That's really like if you do something of this size and you lift and shift that, you're going to have a really bad time until you're able to rewrite that. The other thing that we noticed is AI ingest analysis. So as files land, like let's do object detection. For supply chain, this is not a real-world use case. There's no business use case behind it. It's mostly just hyped, and I need to be specific and say that it's for this specific use case that it's hyped, right? So, and that's because most of the data that we get in, it's already well-formed. So it's being curated by a studio, it's being curated by the content owner. Now, they may have used that as part of their asset management system to generate data, but we're not able to just augment that and pass that on to a third party, right? So we can't go through all the frames and detect, I have a vase at, frame 50, and pass that as technical or other metadata downstream. And then also this notion of multi-AZ. So for a lot of the stuff that we've done now is we have this notion of AZ swim lanes. So if you think of like a pipeline that processes data, where you're potentially passing requests on a large amount of data, we keep it in one AZ with affinity, and then potentially we have a second AZ with a secondary swim lane. So that helps that crosstalk that you get there. So hopefully that's been interesting. If you want to contact me, I'm on the Slack, and feel free to send me a DM. Thanks.